We're just going to do a tiny bit more for the day. Maybe just check out what needs to be done, and then we'll close here because I don't feel like working on anything else. Let's see the layers. We have the block map, block row map, block row reduce, block row map reduce. And we had the trouble with the dimensions for this. And I was saying that I had a good idea, but you know, it's not like I don't remember what the idea was, but right now I don't feel the same urge to quite do it right now the way I did before. So I guess it's time to rest. I still need to think about whether we want to propagate the dimensions the way I envisioned like 2 days ago before I started working on higher ranked types. And then I guess we'll proceed with that. One thing I figured out is that we have an issue in the partial evaluator. I'm not really sure whether I want to fix it, but let me just tell you what it is. Here it is. And in nominal, this thing is what constructs a GADT, and I don't think we're actually doing anything to make sure that the constructor for the GADT cases is correct. We could use nominal create operation, and of course it will check whether the body of the nominal itself is correct. I mean, whether the body of the union being constructed is correct, but not whether its output type is correct. That's I think the partial evaluator should be doing that, but in cases it applies the nominal. Here it calculates it. Union. Oh wait, I think yeah, we haven't done anything to change the union types. Map string type. Okay, I get this definitely, but we really should have the output types for the GADT cases as well. Okay, let's make a test case for this problem. VS Code plugin. And actually, no, we need the compilation tests. And we're going to make a test 100. And okay, well, let's make a union QE equals A, and that's just QE. Okay, let's do QEAT, and this is QEI32 B QEA F32, and of course if we wanted to construct either of these, we can just do it, x equals A. And if we hover over this, we'll see that the type of x is QEI32. And that's perfectly fine. But we can also construct it like this in the real segment. We have this nominal create. And let's take a look at in the partial evaluator what it is doing. Let's put a bookmark here. Here we have the nominal create, and it takes in the expression. This is the body, and this is the type of the nominal. Okay, so let me think. So we should be able to create the something like using something like A, and it takes in a unit type, and then it takes in the type of the nominal, which is, let's see, QEA I32. And this should be QEA R32. So let's try building this and we'll see what we get. Let me just see whether, yeah, we have the F# as the backend, selected as the backend, and then we'll run this and we run it with PowerShell instead of building the file. Now we've built the file, and it returns back the unit. Let's do it like this. Yeah, great. It constructs US00. But suppose we tried doing something like QVI string. What will happen then? The union doesn't have the key A. Oh, really? Oh, interesting. So, oh yeah, I guess this does make sense. Of course, if we put in like I32, it should work. Yeah, of course it would. Okay, okay, I don't know why I didn't think of this. I kind of started to think about it and then convinced myself that there was a bug in the program. So I made an example to prove that there in fact is, and there isn't a bug in the way the GADTs are handled. It works perfectly, which is great news. I guess we'll call it a day here today, and I'll think about, I'll kind of redirect my mind so it focuses on the machine learning library. I don't have really any uses for high-ranked types at the moment, and you know, it's going to be pretty rare that we find uses for them. I just wanted to have them in the language. It really bothered me that I couldn't write that map function a few days ago. I'll see you tomorrow. I'm going to take off for the rest of the day. And tomorrow we're going to get back on track. Hello boys and girls. Let's do a little bit today. Our first mission is to figure out what we want to be working on to begin with. I kind of I didn't really think about this during the night. Instead, for once I stopped playing early, and then I just wasted the time randomly surfing on the internet. So I still went to bed at 1 a.m. and I was obsessed thinking about XCOM. XCOM Long War Rebalanced. And instead of thinking about that, now that I'm here, I need to think about this code. Oh yeah, I wanted to do this tensor dim, but I need to get back the feeling of actually doing it. I need to immerse myself in the game of programming instead of the game of killing aliens. So yeah, I need to imagine completing this library, integrating it with the game, and so on. So let me pause for a bit, and then I'll try to focus my mind on what should be the task at hand. I need to plan things out. It's important to just sit here, have the code editor open in front of me, and just let the inspiration come to me. We did a very good job implementing higher ranked types and putting them into the Spiral language. But now that we have made that achievement, we need to move on to the next thing. Oh yeah, now that we have the benefit of X... Actually no. I thought of maybe we need to wrap this in a type, but it's already in a tensor, so it doesn't matter. It won't be able to split it into a pair. I mean, this tensor type. The problem that we had last time we worked on this is that this block row map reduce needs to return 2 dimensions, but the library is currently designed so it only returns a single dimension. So I'm not exactly sure. Like, I know what I wanted 3 days ago, and that is, I had an idea to make this kind of type, and then instead of returning a dim, we just return this GADT type. That's okay, but I need to think about it again and reassure myself that this is the right path. I mean, who knows? Okay, let me pause here and I'll think about it. I've had time to think about it, and we are in fact going to go with this plan. We're going to make use of this tensor dim data type. I went with the approach of thinking about going with the current design, which only returns a single dimension, but I realized that this gives us problems pretty quickly, so we're going to go with this. Okay, so instead of dim top, let's put this here, and then the only thing I don't like is the naming. Maybe dim off. Too bad I cannot just put a wildcard here. Maybe that's something for a future version of the language. Never mind that for now. In fact, rather than a wildcard, Spiral really lacks various editor support features like renaming. I wish I could just press F2 here and have it be renamed. You can do this by holding Alt and then double clicking. Never mind that for now. Okay, so here we have the demo. And this is going to be DA. Some flies buzzing around. Oh, okay. Okay, now that we have made the decision to use this, we need to figure out how we're going to implement this elegantly, since we no longer have the dim, but this weird thing here. I mean, or here we can probably implement, like, we don't even need to implement anything, just the equality operator just the structural equality operator should be able to compare these two union types on its own. But this one is comparing the first dimension and making sure they're equal to the number of blocks per grid. Okay, what are we going to do about that? Excuse me for a moment. So, do we maybe just simply implement the first function? I mean, it works on demo. Rather than that, I mean, for most of these cases, we just want a single dimension anyway. Maybe we could... just a second. Okay, I want to try preserving as much of the existing structure in this function as possible, because, as you can see, trying to move to demo from just returning the original dimension complicates the code here a lot. So let me try just copy pasting this for now. And we're just going to try taking care of the other cases. Get the dim. I'm going to try to do this as mutually recursive functions. That's how I'm going to try to implement it. So, AB, graph dims, graph tensor dim bit up, and this is just going to be AB. Tensor dim A. Okay. No wait, this is good. This can only be a like this. It could only be a pair of tensors, but we potentially want nested tensors. Like we want to be able to call this function on something like ABC rather than just A and B. I didn't do it right after all, it seems. And oh yeah, this is so bad. I have no idea. Yeah, this is what the type should actually be. We got some experience with the GADTs in the past few days, so I know that the previous construction was wrong. I mean, the previous definition was wrong based on that. Okay, this is the move. Oh yeah, not bad. Let me just pause for a bit. Okay. I got to go away for a bit. Now I'm back. Let's see. What exactly do we do here? And let's keep this commented out. Let's just focus on the pair case. And pair AB. And of course this should be P the A the no wait oh it really is D. Now let's just think, what should we do here? Oh yeah, we actually need to just iterate over this recursively. The pair. And why is this? Oh yeah, we need okay, get him pair F A B. Oh no, wait, and this expects a tensor, this but this A could be anything. Okay, okay, let's make it a single dimension then. Yeah, not bad. So this is, okay, this is a single dimension, so it should just be yeah, like this. And we don't actually need to make this mutually recursive. Okay, and like this. So what we have to do? Okay, I get it. Check A and out. Okay. No, it's no longer the same thing. Okay, what I will do? It's so annoying to extract the first two dimensions of this. Okay, B equals. No, wait. Yeah, not bad. I'm going to put them in like this, and this for out is going to. I'm confused what's going on here. I mean, is it telling me that this output type is wrong? So it cannot compare it. Option graph D, dim of D. I mean, that could be bad. Int TC. Dim of tensor. It results in a dim of tensor distinct TD and distinct TA. And this is. Okay, I understand, but it's kind of. I'm confused. Why isn't it resulting in the correct type? Oh yeah, because it needs to return this T here. But okay, in that case, let me pause here. I need to think about this. Okay, I understand what's going on. I got confused. It can construct this type just fine, but the out type is not the output type, but something else for some reason. Oh yeah, it has an. Oh yeah, I probably wrote the type out wrong. Okay, let's check it out. Block row map. We have the option graph tensor int dim int t, int dim t, int dim int a, int dim b. And we are accidentally shadowing a for all, as you can see. I mean, we are accidentally shadowing a type variable. This a is not the same as the a at the top level. So that's why it's causing us trouble. Okay, let's make a distinction. That's the issue with shadowing. I wrote this far too hastily. Yeah, okay, this one is fine. Yes, okay, everything is fine. Yeah, everything checks out now. And we have this. And the only thing that's still missing is how to handle the the key scalar case. I wish we could somehow also take care of that. So this function is exhaustive. It doesn't have the key scalar doesn't even have a dimensions. I'm not sure what to do with it. I just don't know. Okay, why don't I spend some time actually think about it? I mean, can we do anything here? I don't think it will turn out to be the case. The best I could do is probably to just have the key scalar be a type error. But that getDim pair function it does have a signature that would allow it to be called on an arbitrary type. And lying like that isn't really something I want to do unless I have to. Let me pause. Finally, I'm back. I got interrupted extremely seriously and I had to leave for a few hours. Anyway, at the very least, I had the time to think about what we're going to do. Okay, let's close the primitives. The packages. Okay, we'll save it. And let's make a mutually recursive type. And union graph. Single graph tensor dim t for all dim t graph pair, and here we also have a pair for all a b, graph pair A, graph pair B, and of course that will be the graph pair AB. And why is this an error? Naturally, recursive unions should not have overlapping keys. What does it mean by this? I mean, okay, maybe. Okay, I have no idea what this error is supposed to be. Let's check out the language implementation. Duplicate key in recursive union. Oh, I see. I think, yeah, these two keys are being duplicated. That's what it meant. Okay. Okay, instead of a pair, let's GP single. Oh yeah, not bad. And what we'll do, yes. And now we know by construction that this has to end in a graph tensor dim t. It cannot end in something like a key scalar, or which is a type that might not contain a tensor. Now, okay, block row map reduce. We'll just turn that into a graph pair and then get the dimension of that. And this is a great use for mutually recursive types. Okay, let's go into get dim pair. Okay, so we have a graph dim of t. Yeah, that's perfect. Wait, where is the dim? Ah, here it is. Like, yeah. So, okay, here we have the graph pair PFAB, and we'll have GP single A, and that will just be equal to D of A, I think. No. We need to use get dim on X, so that will be, yeah, perfect. And this thing here, it shouldn't even be in here. It should be in the other. Of course, this is just taking the singleton tensor. But you know, we can just call like Okay, how do I want to get the dimension of this? Like, do you want to just turn this into a something like graph pair, or I mean, maybe we could just turn it into a graph pair. No, this has to output a graph. Let me think. Okay, let's go with this definition for now. I wish this would be a regular graph, but it doesn't really matter. Offset pair AB. Now this is just taking graph pair. But wait, I think now we have to do a special case just for the pair in here. But I suppose that will be fine. It's kind of annoying. Yeah, and I don't want to change anything else. Okay, let's leave it like this for now. We have this pair. And I wish it wasn't like this instead. Tensor DMT out graph tensor DMT. It's really amazing how difficult this is for me. Like, all I want is a very simple construction that we had previously, and now I'm getting burned in this shit. Doing this node was the worst idea ever. It makes so many other things so complicated. I'm not people here. I'm way too scatterbrained right now. I stepped away for a few hours, and now I need to get into the zone again. Even though we're just going to go to the beach in like half an hour, so I don't even feel like doing this. Yeah, seriously, this is such bullshit. But I guess that's life. Maybe instead of playing games today, I should do some programming after I get back from the beach, even though it will be past 6 p.m. You know, I should at least properly get into it so I know what I should be doing tomorrow. We'll see. I'll do whatever I feel like doing. But this kind of frustration is actually good, because it really builds motivation to resolve the problem. I'm not going to be doing much speaking. I just want to listen to the music in the background. I've gotten some good momentum going here. We'll do a review after I'm done with this. This is what I am listening to in the background. It's by the same studio that did the music for Punishing Grey Raven. Oh, I see. I did this a little bit earlier. So how are we going to do this case? Let me pause. I've been thinking about this and an idea comes to mind. The key is to have all of these be uniform. Now, the outputs of all of these nodes are graph pair. And with that in mind, we'll have to change all of these. No, this definitely doesn't need to be recursive. Why cannot I just wrap this A in a D and then pass it into this function? We have finally come to this point. Now let's see whether we can actually deal with block map row reduce. Oh yeah, it cannot be dealt with here. No, the things are like this. The cutscenes for this game are very good. Let me pause. My brain really isn't working properly today. Yeah, we just need to do this. This is so annoying. Let's. Oh, this is different. Wait, how the hell do I turn this into a graph pair? This is such a struggle. Let me pause again. I thought what I was doing was a good idea, but maybe it isn't. Okay, I give up on this approach. Forget this. Rather than making my codebase better, it's just making things more complicated. I think that novice programmers tend to act like this. They get a new tool and then they try to, make full use of it. But that just ends up making things worse. And I think that is what is happening to me right now. Okay, what are we supposed to do here? Let me pause here. I don't understand this type error. After thinking about it, this strikes me as an language error. It doesn't make sense at all. But to make sure, we're going to make a function at the top level just to try it out. Okay, it's going to be some trouble trying to figure this out. We're going to have to stop what we're doing in order to debug this. Let me just we're going to have to isolate this further. What if we did it like this? Match oh, now it works. Interesting. I need to think about the scopes. Oh, I see. Yeah, now the error goes away. Okay, I'm kind of starting to get the picture. This is the same error as when you try to destructure a type case that's raw. I mean, this is the same error that you get when you try to destructure a type case directly without the for all. I'm just confused. And this is dim of t. And yeah, it has a bunch of meta variables. No, it doesn't actually. I mean, none of these are meta variables. Okay, I mean, if I put like dim of t here, for example, dim of, yeah, that works. And then match QEA. Yeah, now we don't get the error, but now we do. Oh, I see. So when it gets into this match case, it still has meta variable. Okay, suppose we tried doing it like this. Oh yeah, now the error also goes away. Okay, I see. When it gets the reason why this is happening is because when it first tries type checking this, it doesn't actually know what the type of out is, even though when you hover over it, it shows you the complete type. So that's a bit of a confusing error, especially in this case. It's not really a language error. It's not really something I can do anything about. It's simply the way the type inferencer works. It works from left to right. And if the necessary information isn't there, then it would show these kinds of errors. You get the same error if if out is some kind of record type and you tried indexing into it. I mean, if you put it out here, and that's why instead of having this form in spiral and F sharp, you'll often see it like this. I mean, in F sharp and in spiral, I wouldn't blink an eye regarding this kind of error, but because we're dealing with GADTs, I got taken by surprise. I guess we'll resume work. Let's just deal with this. Finally, let's resume. Right now it's 7:10 p.m. Usually I'd have long stopped by now, but I want to do a bit more because I didn't get to do it earlier. I forgot what exactly I was talking about. But you know, exploratory programming, like you're a novice, is a necessity. It's not really something to be looked down on. Trying out various designs and seeing which one of them work is a path to getting better at programming. I'm not sure whether what I'm saying here is a non sequitur, but I was talking about novice programmers at some point. And I think, I don't want their behavior to be seen as, negative. It's a reasonable thing to play around. But, when you're experienced, you should be able to go directly to the correct design. And regarding this design, it was, 99% correct, and now I was getting anal about that other 1%. Try to get it exactly right. But, it's fine if the design is 99% correct, and since this other 1% that is broken is going to be type checked anyway during the bottom-up segment. There's only a real need to have it all be completely correct by construction. It's much easier to do it this way. So, okay, here we have PDA, PDB. Okay, let me think. What are we even trying to do here? We're trying to assert. We're trying to. Yeah, the dimensions. Okay, but demo of tensor i32ts, i32, i32ts tu, and what the hell? Demo of tensor txty, ts. I mean, it keeps introducing new type variables, so it's confusing what the hell this is. I mean, there's no way around it. Okay, here we're going to have to. Yeah, we have to do the assertions. Okay, first of all, we have to assert that okay, FQA okay, first let's assert that QE equals A. Yeah, that's the first thing that we need to assert. And we should maybe, I mean, who cares what these variables are? Never mind that. And we should assert that QE equals B. Oh, here it's showing up in a sensible way. Okay, that makes sense. Okay, we have asserted this, and by extension, we have asserted that the first two dimensions of A equal B. I mean, you get what I mean. Dimensions coming from the input and dimensions of the output have to of the first of the second output. Okay, this makes sense now. Row map reduce. Yeah, okay. Here's how we're going to do this here. P D Q A Q E yeah. Yeah, this is perfect. This is exactly what I wanted from it. Now, are we using this check anywhere at all? I don't think we are. So let's get rid of it. And in this function, we also have to take care of the pair case. Let's see. Pair AB. And then what? Inal AB equals f of A, f of B. Then what do we do about this? I mean, like, we're going to do nothing actually. B. So, is this not correct? Oh wait. Yeah, like this. Yeah, now that we're using JDTs, it's putting these weird. I mean, it's constantly introducing new type variables everywhere. It's atrocious. But it cannot be helped. So yeah, now we have to get the impair, and it can take an arbitrary graph node and return a dim off. Of course, if it doesn't get a oh yeah, if it gets any of the other nodes, like then just return D and then f of what? F of x. Why is this creating trouble for me? F equals x graph t. Oh, this one's a tensor. Oh, what a problem. I mean, I don't feel like writing out all the possible tensor cases. I mean, there are a bunch of them. I mean, there are not that many of them. So what should I do here? I think, yeah, shouldn't this be a type error? I'm not sure. I mean, these are all tensor cases. Yeah. We need block reduce, block matrix multiply. Block connector zip. Oh, wait. Oh, input. Key tensor. Apply. Yeah, I mean, it has to be done like this. And then if we stumble upon the key scalar case, then we just get an error. Yeah, this is yeah, it's pretty awkward trying to write out all of these cases like this, but that's how it goes in compilers, which is why it's not really that fun to create a compiler. It's much easier to do regular functionality in a library. And once you have a library, I mean, even once you have this machine learning library and we're done with the compiler, we won't be really doing much at the lower level. Instead, once you have a language and a library, you do things using composition of higher level concepts. And this is low level stuff. Now we're done with getDim and getDim pair for good. Now we can think about what to do about this. Graph hair doesn't even exist anymore. So far so good. Dim isn't being used anywhere, but in this particular place, so you'll inline it. Hmm. Hmm. Okay, this is something to think about. Here we have gravity. Let's focus on this for now. This is what got us stuck last time. So we have a gravity, but and we could get the dimensions of it, but what exactly will we use for the keys? Like these partition offsets, we need two of them. I mean, we've had one that we. So we have demo. We need something. I guess we'll have to also create a new type for the arbitrary partition offsets. There's no other way we can really map them to T otherwise. This will have to loop over the dimensions of T, something like demo of T, and the individual bodies will get turned into partitions. Yeah, I do get. No, let me pause here. You know, maybe we'll leave this for tomorrow because it's almost 7:30, and at this point I am tired. I don't feel like programming anymore. Well, but today's session was good enough to get back into the swing of things. It really got me started again. Yeah, see you tomorrow. I really can't wait to finish this library and integrate it with Ladakh. Once we cross that threshold, it will be. Things will start to get more interesting, hopefully. But you know, if you are into compilers, maybe you've been enjoying what I've been doing so far. Maybe you're disappointed that I didn't do back propagation. If you are disappointed by that, post it in the comments, and maybe we'll do a proper video on putting back propagation into the machine learning library. Once we are done with all of this, the back propagation would actually be pretty easy to add. We have a graph, and the backwards path can be derived directly from it. So it won't be so difficult. The difficult part of all of this is the design. When we started the work on this machine learning library, we didn't even have existentials in the language, and now we have existentials, generalized algebraic data types, and now higher ranked types. Working on this machine learning library has really caused the language to evolve. And yeah, this is how programming should be. Instead of just getting fed some scrappy language made by a corporation, we are paving our own way here. Let's do a little bit today. The camera is working, the mic is working. I want to make the same mistake as when I made the GEDT video. So let's get started. Okay, the pass offset parameters. Okay, I think this is right. And now what we have to do is pass offset output. We did this yesterday, and we have to get rid of it now. Yeah, I really wanted to tighten things up at the type level, but it's been very hard. It's easy to get 99% of the way there. Okay, I already said all that I wanted on this subject. So let me just turn on the music. I'll focus for a few minutes on this. I need to get started for the day. It's almost 1 p.m. I didn't do any work. I'm really enjoying myself playing Long War Rebalanced for the original XCOM game. Actually, I'll let you listen to the music as well. No, wait, that might get messed up in the audio post-production. I don't want to risk it. Let me factor this out for now. Wait. Oh no, wait. Wait. These partition offsets, yeah, yesterday I remember wanting them to be a component type here. Yeah, they're going to have to be a component type. Wait, how will that work? Okay, let's do... Okay, partition offsets. Is it like this? I think it's like this. I should have put a bookmark on the thing below. Okay, let's... This should be like this. At least this much is easy to understand. But don't I just have the compound type? Maybe I can factor these two out. Oh, just a second. FT. No, I mean, no, this F won't be the same everywhere here. We have to vary it based on the dim. I mean, we have to vary the size based on the dim, and using the compound type won't do what we want. PD, DD. But maybe we can make an alternative type. And something like a regular. Maybe. I mean, this tensor DMT could be part of T instead of F, like here. Whatever. Let's do it like this for now. It's actually clearer to understand what needs to be done. GDTs can get difficult pretty quickly. The I really have to change all of this, but so be it. Okay, so this returns partition offsets tensor TCT. Yeah, perfect. And we want to add them to the hash map right away. We will increase the offset counter. And what will return from here? P D. Okay. Partition off. Oh wait, so like this. Not bad. Now, what you have to do is PD, and we'll just put this in. Yeah, not bad. And now we'll add this structure to the hash map. Yeah, not bad. Okay, now here we have the pair. And this is passed through. So we can just make it like this. It's no longer returning the offset. Yeah, also here. Maybe I can factor some of these out. Geode. Not bad. We'll just leave this comment in case somebody reads this and thinks I'm an idiot for not putting this in a single clause. Yeah, okay, this is pretty good. So what do we have to do now? Pattern init. Graph tensor extract. Yeah, it's expecting this to be partition offsets, but now it will be partition off. And that's really a problem. Hmm. This is parameter offset, and this is output offset. Great, now we're giving it the correct rotation, and we have to go over this. We have to convert this partition off to the individual types. Okay. Partition. And that's P and D and X and really this we're actually shadowing this. Oh, here we have the T over here. Let's change this into T top. Wait, what exactly is it expecting? Okay, there's no way that this is right. Oh, why is this a problem? It's expecting T. Okay. Oh yeah. Okay, I see. P. And this will have to be yeah, loop a loop. One thing I'm thinking about right now is to stop this video. I mean, after this video, to make a video on how to do pen highlighting. You know, this thing you see on the cursor, this green circle. It's actually done through the Windows Power Toys. And we have let's see. Mouse utilities, and this is the mouse highlighter, and you can activate it and deactivate it using a shortcut, and you can modify its behavior here. It's actually very hard to find information on this on a search engine, so that's why I were thinking of making that video. It will be like 5 or 10 minutes at most, so it's not a big deal. Actually, I'm going through this too fast. Focus, key extract. Oh yeah, that could also be. Okay, tensor. Right, is it necessarily... Can it be a pair? No, it cannot. Parameter init, parameter print. Let's write this like... Does I have to change? It's kind of... It's... I get whenever I do this, I kind of get the sense that it's difficult to convert the arguments to arrows, and that the language syntax could be better in this case. The same goes for converting regular statements into record fields. It's not too difficult, but it's difficult enough. Okay, this is key extract. So you cannot really put the key anywhere. It would actually be better if we could put the key tensor wherever, but I don't feel like changing this right now. It's just too much work for no real benefit. Raw. Okay, this should be raw map reduce. I'll just get rid of this. It's on the same output anyway. Now, what was the problem? Oh yeah, there's also the input function, but I32. Oh wait, and this should be a float. Oh no, this should be a T. Let's pause here just for a bit. Let's resume. We got this then. Okay, this there is good. Yeah, now we're going to go from the top. Float tensor to int. And you know, now that I think about it, we should just we should be putting this here. And then let's change some of this stuff. Oh, no, wait, it's not the D2, but int dim int. Never mind. Okay, we're going to have to start with test 3, but of course we first have to get everything else back into shape. Okay, we'll not be able to actually do that. I'm going to extract the tensor, graph tensor extract. Yeah, we do have this here. An idea occurred to me is that we could actually maybe even implement the tensor types using GADTs, but it's a different thing. The GADTs are union types, and we don't want them to be heap allocated. No. They'll have to be recursive, so they'll be heap allocated, and we don't even want them to be stack allocated. So the way they're going to implement it. Also, I'm not really sure that we could do all the operations with tensors like we have currently. So yeah, I like the way they work currently. We are doing a lot of bottom-up stuff to make them work, but that's fine. And over here in the ML library, GIDTs are in fact what is necessary. We could probably do all of this using the bottom-up magic, but it will be a lot harder. Okay, so extract. Test 5. And one variable mask. Okay, but we also have some kind of error here. What's going on here? Oh yeah, we need a pair. So what's going on here? Oh wait, I got it wrong. This has to be try the so in 716 I guess this will also be 16. Oh my god. Q. I just put this here so I can see what it's actually doing. It should be D3 float, it should be D3. So what's the problem here? Okay. Yeah, this is much better. This is, yeah, I think this is pretty readable. So I don't usually format my code like this, but this time it's fine. So let us think. Yeah, we have to. Yeah, here is extracting the output key. This will now be the output indices key. And okay, this is test 5. You know what? Let's just comment out test 5. We're going to deal with it last. We're going to start things off again from the very first test. Time to start. Okay, where is this? Online 67. What are we doing there? 67. Oh, this is memorize. Get the impair. No, it what? I mean, if it's in the key, why is it trying to add it again? Like, it should just return the result. What the hell? I mean, this is get the impair. This is on line 189. Okay. Do I see this? Here are the dims. Wait, what's going on here? We're creating a hash map. I mean, that hash map doesn't have to do anything with the one in dims. Yeah, this is why I'm starting out from the very first test. You never know what's going to get broken. The entry with the same key already exists in the dictionary. Okay, let's just put the print static in. I have no idea what the problem is. Okay, so now print. Like, a trigger in this case should be absolutely impossible. So, okay, let's go here. We'll close some of these terminals. Yeah. What's going on here? So we have the input, like, it gets here 3 times, but oh wait, I know. Oh yeah, this could happen if this input type appears recursively. Wait, maybe I'm kind of getting a sensation. This you can get an error like this. In fact, if you know, here we have the hash map try get hk, and if it tries to apply the key again, like in the function itself, then it might first add it, and then it would try to. It may first add it in the function itself, and then add it here after that's been done. And that's how this error could happen. And but this error is a symptom of it's a symptom of passing or executing the function on itself, maybe. Okay, let's see. What's this gx? Oh, I see. Yeah, take a look. We're memorizing with the graph dims here, these nodes, but they'll also be memorized in get the dim itself. So that's why this error is happening. I think the solution would be to maybe just get rid of this function. Yeah, we're going to do that. Just a second. Let me get some water. We're getting rid of this. I mean, we're going to have to pull the functionality for this into these functions. Okay. Whatever. Let's do it. Let's do it. Block map. Zip weight input cadence apply. Yeah, not bad. Oh, wait, what happened to the pair? Okay, this is going to be a bit special. Get the H. Actually, this will be F quote, and then we'll match on it. Match with, and then dx. What's the problem? I cannot. No, let's make this theta. For all. Oh yeah, graph. Tensor DMT. Oh, not bad. Oh, we're just going to do it like this. Okay, and this is check. D. Oh yeah, not bad. And here's the pair case and the block row map reduce. And we can just make this. Actually, we'll leave it as get dim pair, and this F will just be get dim. Okay, well, let's move it out. And get dim pair h not bad. And we'll implement this in terms of get dim. We don't need the type annotations anymore. Yeah, I really like this now. I really like how this DDD, this DD is the only possible case that could be the output of this. So it's not even inexhaustive. If we tried putting the px, and we just get a unification failure. So it can only be this DD case. It's amazing. Yeah, I think your programming skills can really progress if you have powerful type system features like GDTs and you use them. The same goes for partial evaluation. When I did dependent type programming back in 2019, after doing a lot of programming in the early version of Spiral, that really upgraded my skills, and it's the only reason why I've been able to even do dependently type programming. It improved my reasoning capabilities as a programmer, so I could do more in the end. Right now, what I'm wondering is whether TypeScript has something similar to GADTs, and I don't think it has, at least as far as I know. Let's do a little search. TypeScript GADT. Approximating GDTs in TypeScript. Okay. What's this Leibniz? If extend URIs, if I can, if a can't, FMB. Oh my god, who's going to understand this? What squares? It takes in this Leibniz thing from A to B and turns it into B. Return I, proof, URI, I. What's this URI? Wait, what's this identity? Okay, sorry for wasting your time, but I'm kind of curious. Yeah, we can now do this in Spiral. Oh, in Haskell you have two columns, and does it actually use two columns for regular unions or just a single one? Has union function? What the fuck? Just give me the union types. Union recon types, data union, extensible types of unions. Why is it giving me the package packages? Okay, let me try Google. Haskell union type synonym. I guess it has some types, maybe. These languages all lack user-defined subtypes. Burn. Data bool equals false or true. Okay, what about give me something a bit more complicated so I can see the fucking syntax. Okay, where is this union division result? Data division result success the double. Really? Is this the... Okay, give me some... Oh my god, this is... I'm trying to get to find a Haskell some type, and it's giving me some very weird short examples. Even though I'm just trying to find out the syntax. Let's get screaming. The search engines are absolute shit these days. Give me some type example in Haskell. Person string. I mean, this is really the syntax for union types in Haskell. I mean, doesn't it have something like a colon to separate out the stuff coming in? I don't string. I mean, they're not even separated out with pairs. Okay. Give me some other examples of some types in Haskell. Also, so this really is the syntax for some types in Haskell. It doesn't separate them out with stars, like in F# and the spiral, like they were product types. Instead, they're pretty much very minimalistic. But gedits do require a double colon, so that's how it works. I mean, I knew that like 5 years ago, but I've forgotten it since then. Yeah, this is how the gedits are in Haskell, or maybe this is a camel. I'm not sure. I mean, it's talking about Haskell here, so this is 99% Haskell. I'm not sure how it would be in camel. I never actually programmed in it. I mean, I expect it to be very similar to how it is in F# and in spiral. Type committee. New type Leibniz for all FA FB. I mean, I think this is something that I need to really study a bit myself, because okay, this construction to begin with would require higher candidate types. I mean, we only added those after we added the gedits. What's this TLD operator here? I have no idea. Infix type 4. So it's encoding this Leibniz thing as the tilde operator. Okay, I cannot understand this right now. I have to actually study it for an hour or two to understand what's going on here. And it doesn't really matter, because it's actually easier to think in terms of gedits instead of some weird construction that approximates them. That's how it is. Everything you do in spiral, you could also do in C, except it will be a lot more verbose. But that verbosity has a significant mental cost. The more you can fit into your brain, the easier it. I mean, the more efficiently you can fit things into your brain, the higher the complexity ceiling will be. So if you can make only simple programs in C, you'll be able to make very complex programs in something like Spiral. TypeScript, as a counterexample, doesn't need gedits because it has first-class unions, void plus nice type filtering. This bit of manual tagging is needed term. Indeed, gedits provide type qualities and these essentials. I guess they're talking about this particular example. Okay, let's get back on track. This is just a digression. So yeah, we redesigned the getDim function. So now it's using getDim pair. Now we can get back on track. Let's try building it again. And we're getting another error. Yeah, I cannot find the backend F#. I mean, we're trying to compile this with the wrong backend. Oh, and it did compile. Let's try running it. And this example simply just initializes all the layers. Cannot find the offset in the dictionaries. Check the output in the terminal to see which node it is. So I'm guessing it's the input node. Let's run it again. Oh yeah, it's this input node, and it cannot find the thing in the dictionary. Now we need to figure this out. Line 313. Okay. 313. I mean, okay. I mean, this should definitely be calculated in pass offset output. So, okay, here we have the input. Here we have the none. The option is Meraki. Getting Perky. Oh crap, here we are shadowing it. Okay, let's try it again. Oh, here are the weight matrices. Here's the input tensor. Okay, not bad. Now, on test 3 we also have some error. Pattern miss. Got block row map reduce, and this is on line 262. Okay, which function is that? 262. I must not forget to press enter. And yeah, we need the block row map reduce over here. And for once it just works out of the box. Okay, not bad. Let's try running this again. Another error. Another pattern miss. This is on line 286. And that would be here. I mean, and another pattern is 352. And I get the sense that it's going to be another pattern miss. We got 236. Okay, let's see. And did I even... I get the sense that I should be doing something in graph run. Graph run. Like, I pretty much did nothing here. Okay, let's copy this. Oh, so we need 2 of these. What is this ABI? Apply block index. This needs to be raw map reduce. And oh yeah, okay. Let's try running it again. And I think it actually built. Let me just check that it's not crashing. I didn't. Okay, something is getting printed in the console. We should disable that. Print static. Oh yeah, this thing. Oh, wonderful. No, it's really good. Yeah, this looks like the softmax. And this is the output. Yeah, definitely. Very nice. That's test 3 done. Now we'll run test 4. Another error. Cannot find the offset in the dictionaries. Okay, what the hell is this? So it cannot find the offset for block row map reduce, I think. Is that right? Yeah, since it's at the very top, it shows me the entire graph. Okay. Now where is this error happening? $313. Okay, 313. Let's go there. 313. Okay. I mean, it did extract it a while ago, so why is it complaining right now? Okay, well, let me just take a look at the example. Where did I put the mark? This is in primitives. Let's disable it. Okay, this is in layers. We don't need it here. Let's take a look at the example. I mean, what's the difference between it and... Oh yeah, this one has a pair. So the one that allocates directly works, but this one doesn't. So you're going to have to check it out. Oh no, let's think about this. Here we have the block row map reduce case. We have the pair case. I mean, no, we don't need to be using out anywhere here. And this, yeah, this will have the out. Oh yeah, and it's not getting added to H offset output. Okay, I see. So, where is it trying to extract it? I think in 3000 line 313. Yeah, it's trying to extract it here, and we are missing the block row map case. What the hell do you do? Oh yeah, we were missing this case, so it wasn't extracting it. Okay, let's try building it again. And it's not crashing. That's always a good sign. Oh, nice. Oh, very nice. This is super nice. Okay, we are not done yet. We want to do test 5 as well. Now I have to refresh my memory of what exactly was I trying to do here. I mean, okay, here we have the mask and the discrete sample. I don't think did we ever implement the mask function directly? I think we started work on it and then dropped it. Instead we did the masked softmax. We're going to do this. Masked softmax and discrete sample, and we actually need to implement this. Okay, so here we have the masked softmax. Oh, can I move this to somewhere? So this is the masked softmax. And I think we do have in the masked softmax followed by discrete sample in the primitives, maybe. Unless I forgot to implement it. Local softmax and discrete sampling. Oh, districts in two inputs. Local masked softmax. Okay, I don't think we've actually implemented that, so we're going to do it here. Masked discrete sampling. And this has to take in a masking function. And we put it first on the second, and let's put it first. Because the RNG will be applied later as part of the layer state. That's why I'm putting the masking function first. It's also, the masking function won't vary. It will be derived from the schema. From the schema size, I mean. So local masked softmax. Oh really? We actually do have this. I guess we simply didn't bother to test it. And we'll do that now. Let's just go comment this out. I don't feel like. Now let's build this. And it's building. And we'll see what it gets. Oh, it's yeah, it's picking the action from 0 to 4. Uh, 1455. Yeah, that's fine. Oh wait, this is the okay. This is just the mass softmax. Oh yeah, they result in the same thing. Okay, perfect. Now we can implement what we need with this. And in the masked softmax, we are going to take in the size. And the masking function will be what? Full config xij tensor. And we'll be testing that. No, it's not taking in j tensor, just j. And j less than size. Yeah, this is fine. Sorry, I've gotten a bit distracted. And okay, let's give this a try. Output probabilities, output indices. Yeah, I wonder what we'll get. Let's build this. Going to the sidebar, and then we'll run this. Control F5. I mean, did we even build this? Did it maybe crash? I mean, we have the output probabilities, but I don't see... Wait, oh, just a second. Like, I'm not really passing the size. Oh, right, yeah. We're fucking calling the wrong thing. We have a type error. Yeah, and I mean, we can imagine where that should be. Let's just set it to 4. Now we'll build it, and it's probably built. Let's take a look at the Python debugger. We run it. And it's picking 12 here. 4, 8. What? Okay, it's masking all but the first. It's masking out all but the first 4, and that's good. But if you look at the output indices, they're very weird. 4, 3, 12, 4, 1, 0, 8. What? Okay, the output indices are definitely not right. So something is weird is going on with them. They should be from 0 to 3. When we ran the primitives, it did work. It did work on this file, and as you can see here, they're from 0 to 4, 0 to 3, I mean. But over here, they aren't working for some reason. Yes, they aren't working, and we need to figure out why. I mean, the problem is probably in this function. mass softmax and discrete sampling. J has to be less than size, RNG. I mean, is the problem in local mass softmax and discrete sampling? I guess let me print out this size here. Print. Yeah, this is 4. This is completely as expected. So then okay, let's make a commit here. Minutes. Okay, let me pause here. I need to think about this. How exactly are we going to resolve this issue? I mean, I can only assume that the problem is in this kernel, but what exactly could it be? I mean, do we put in a print statement? Do we put a print statement in it and then I mean, would the softmax be sampling something wrong? So, I mean, sampling something incorrectly? That could also be a possibility, but you know, I'm looking at the probabilities here, then they seem sound. It shouldn't really make a mistake. Maybe they could also be a mistake in the reduction functions. Who knows? Who knows at this point? Okay, let's put in a print statement and we'll see where that gets us. Oh damn, it's really hot today. I think another heat wave is here, and it's been cool. It's been a bit cooler for the past few days. Okay, core CUDA. Here are the primitives. I mean, you'd expect this to be solid by now, but I guess it isn't. Okay, let me pause here. I don't want to bother you with this. I'm not sure myself, and I'm just staring at the screen here, which... I mean, not many people are watching these screencasts, and just watching me scratch my head here can't be any fun for anybody. I mean, I'm not having fun right now. I hate debugging. Let me pause here, and I'll get back to you when I figured out what's going on. Oh wait, I just ran the example, and now I see something interesting. We're getting nans here. Nan is not a number. So Yeah, that would mess up the comparisons. Okay, it's very interesting that this is happening. It's the first time I ever seen this happen. Okay, maybe that's due to me putting in the print statements. Yeah, maybe this is because of simply because of the print statements. Let's comment this out. Of course, now I think the nans will, yeah, the nans have gone away. Oh, damn. Let me pause again. I figured out what the problem is. Right now, what I'm doing is printing out these probabilities here using the semaphore right align system. And okay, this sort of seems sane, but this is crazy. Like, you should be subtracting the probability from x, and all the x's here should be 0. But we have positive values here instead, so that's why it's sampling them. And one thing that we have to keep in mind is this probability here. I just realized it, but it's actually generating a separate probability for every thread. And instead it should be the same probability for every thread. We have to share this value across all the threads. This is a serious mistake. So, okay, this is one mistake, and I also want to print out what's going on with this inclusive scan sum. That's also suspicious for me. Let's check it out. I mean, the only thing that's really amazing to me is why did the text example in this primitives module even work? That's what boggles my mind right now. We'll get to that later. For now, let's just try running this, and I want to see what gets printed. And since we're doing a scan sum, the value should be from 0 to 1 ascending. Yeah, this is perfect. This is exactly what you'd expect. There's a very weird error on the CUDA side. It sometimes drops characters incorrectly. Maybe this is something I should report to Nvidia. I mean, I'm going to get to that later. Never mind that for now. Oh, 0. Yeah, this is okay. 4, 6, 7%, then it goes up to 100. 2, 7, 96, then up to 100. Yeah, this makes complete sense. So at least the scan operation is working as it should. Okay, let's where the hell am I? So the problem is definitely this that we are generating a random probability, that we are generating a different random probability at every step, while we should be sharing it. instead. Okay, so how are we going to actually share this value? I mean, could we do a reduce? How are we going to reduce it? I mean, there should be an easier way of sharing it, like. Yeah, what I want to do is make a local share. Let me comment this out. And I talked about this before. We have to make a shared variable and then assign to it. So local inclusive scan. I mean, we could implement this using a reduction to. I mean, let me show you how this could be done using a reduction. Here we have the probability. And then local reduce config. I guess 0 should be the neutral element. And then fun. Oh crap, we also had to. We also need to put in the index manually. God damn it. Okay, local map config fun xi j tensor, and no, actually this should be just j, and j will map our j tensor and put in j next to the output probability. And then using that we do a reduction. And this is AB, and then if okay, second A less second B, then A else B, oh no, what's the problem with this? Yeah, this doesn't need this doesn't need the config. Raw config neutral element tensor. I mean, what's the problem? Let me pause. Oh, I figured it out. So. We also need a neutral element for the index. How annoying. So yeah, we could share the value like that, and I'm interested what will happen. We'll let it do the version that does this much more efficiently using shared variables. For now, let's just get this to run. It has a type error somewhere in its path. Really? Why would it? Oh. Okay, so let's go into the layers. Then we'll build this. Then we'll run this. And I forgot to turn on the print statements. For fuck's sake, we're still getting the same problem. Let's print out the probability. Every thread has a different probability. Yeah, damn it. No, but actually... Oh yeah, this should be grouped into 4, I think. Like, if we didn't do this, every thread should have its own probability instead of every 4 threads of... I'm just surprised that this didn't resolve the issue. Let's try printing this. Now every thread should have its own probability instead of it being shared across the input dimension. Yeah, as you can see now, every trade has its own probability. And even though we were sharing it, that didn't resolve the issue, which is very strange. Wait, something is going to... Could it be possible that I did this function incorrectly? What we will be doing now is printing out the probabilities. No, not this, but I wanted to print out the x as well. Okay, focus me. X probability thread ID log index. Okay, so here it should be picking 1 because this is the element that's greater. It has a probability higher than 0, but it has a probability that's closest to 0 while being higher than it. That's the way that we are doing the sampling in the kernel. First we test whether the first value is 0, then we get the lower of the two. That's the way it works. So let's take a look at 0, 1, 2, 2, 2, 2. Okay, it seems we're never getting 3 for some reason. Okay, let's first find the example that has 0 as the first pick. We shouldn't be hard because the 0 will end up being positive. And this is 2, 2, 2, 1, 2, 2, 1. So this should be 0. It's 28. And this, I mean, I guess this should be, it's telling me this should be 12. This should be 4. 1. Zero to 12. Okay, let me run it a few more times. We'll get an incorrect value, so we can get an incorrect value at the very top. Oh, it's right next to the first. Okay, great. So this is 1, and this is supposedly 12. Oh, if you look at it more carefully, we're never getting 3s over here. We're never getting 3 here. We're just getting 0, 1, 2, and then these 12s now. Yeah, it's different from the errors that we've gotten originally, where they'd be 8 and so on. So when it gets a 3, it instead outputs a 12. That's what I am getting from this. Okay, I see. Okay, that's illuminating. So we understand the issue somewhat. So why isn't it outputting? Why isn't it outputting 3 here? Okay, let's go into the primitives and then. What exactly are we? We're zipping the X with the J tensor. Like, is this a reduction function passing the arguments in the wrong order here? I mean, we had that kind of issue in the past once, I think. I thought that I made. I thought that I had fixed this, but I guess I didn't. Okay, so here's the local reduce. Of course, it first just reduces the local elements, and then it does a block reduction. Reduces the individual thread elements. Block reduce 2D. Threads per mini block. I think the threads per mini block should be 4. So it's going into this case here. Create a partition. And then we do a CG reduce. And don't tell me this is wrong. I mean, I didn't really test whether it's passing the arguments in the correct order into this. And this should be in, I think, oh yeah, is it in pipeline? No, in cooperative groups, yeah, in cooperative groups. CG reduce. Maybe it's maybe it's passing the arguments the wrong way around in here. Okay, as an experiment, let's try just swapping them here. I mean, if this turns out to be the error, then the good guys are really incompetent. Yeah, I think this is an issue in the CUDA library. It's been passing the arguments into the function the wrong way around. God, for fuck's sake. Oh, this is. Okay, but actually, maybe it's also a spiral error. Let's think about this. We're going to make a macro, and then let's build this. And if you look at where the comment is going out, float tup 0, float tup 1. This is float and an int. It's doing a less. What's this less thing here? Why isn't it less than or equal? Wait, could this be an error in the spiral code generator? I mean, it shouldn't be greater than, but simply less than or equal. So, cogen CUDA. Okay. Where is the GT? Okay, how do we search for it? Okay, let's go into block parsing. We have all the operators here at the top. Let's see. Here is GTA, not equal, equal, LTA. Okay, let's do a search for LTA. GTA. Yeah, this is fine. What about it being in the partial evaluator? Yeah, it's pushing LTA here, and this is fine. So where is this less coming from? We're going to put in print statement in let's go into the primitives. Okay, this is gg reduce. We'll put in a bookmark here, also a bookmark here, and we want to put it in the kernel that we are trying to debug. Let's see, write ln, yeah, it's here. Let's put a bookmark here. Tradition. What do I put here? Should be no. Let's put let's just put this and then build this and the QA. Before does with 0 equal greater than 0? Wait, what? It's also checking whether the v2 is greater than 0, and if both of them are, then and if they're true, then it's returning, yeah, the first one. Otherwise, it returns the second one. I mean, that's how it should be. Of course, if I switch this, then it also switches in here, and now it's returning the wrong tuple. But if we run it, we actually get the correct results. So in other words, the arguments that are going in here are wrong. Okay, let's leave a little comment. But that also raises the issue. If these arguments are wrong, then these are probably wrong as well. But you know, since we are dealing with CUDA developers, we cannot count on anything. We're going to have to test this. And okay, here we have the inclusive scan. So what do we do about this? How would we even test this? Okay, let's go into the primitives module and we'll make a test. And this test will be simple. Okay, we don't need this print statement anymore. Okay, raw map. Fun AB B. And what will pass into this is J-tensor. So output scan order test. For fuck's sake. Now let's build this and we'll see what comes out. Wait. Yeah, we need to remove the print statements from. No. Okay, 0, 0. I guess this is an exclusive scan. 0, 1, 2, 3, 4, 5, 6, 3, 8, 9, 3, 12, 13, 14, 15, 3, 3. I'm confused. I don't think it will fuck up like this, but I guess when it comes to CUDA functions, that's a given. Okay, where did I put this thing? Order scan test. Let's put that at the very end so I can see it. I mean, what if we simply outputted the J-tensor? Yeah, that of course gives us what we'd expect. And if you do, this is an exclusive scan, let's do an inclusive scan. And so you can see what was exactly that will give us. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. Okay, the inclusive scan does make sense. But the exclusive scan, I guess that one is shifting the variables around. Just for the sake of the argument, what if we tried swapping here like we did in reduce? It's very weird that there's no difference. Just a second. What the hell? I mean, we should definitely not be getting them in the right order, I think, since we're always returning the leftmost. Like, how could that possibly work? Okay, let's try something. It's actually quite difficult to figure out the correct test when you want it. I'm going to have to think about how to actually properly test the order. I mean, it ends up being the same thing, no matter what I do. Let me pause here. I need to dwell on this for a bit. Okay, I have figured out the test. I've simply neglected to do something very obvious here. Here the inputs are actually pretty large, and we need them to be small in order to actually test out the inclusive scan. Let's build this. Okay, here it gives us zeros. Now, if we swap things here, what will we get? I mean, we probably shouldn't be getting zeros, but instead it should be returning the right side. Oh, no effect. Maybe there are multiple swaps happening, which ends up cancelling out the error. I mean, there could be multiple wrong swaps happening, cancelling out this error. Yeah, here we have 0, 1, 2, 3, and when we return the A, we have 0, 0, 0. I mean, that's the behavior that you'd expect. You'd expect there to be zeros everywhere if we are just returning A. But the thing is, we should be getting the opposite effect if we swap the arguments here. Local inclusive scan. Actually, maybe these inputs are too small. In fact, this is enough to fit into a single thread, since it will be loading one at a time. In order to actually test them, we need to make them just a tiny bit bigger. Okay, let's make them like 16, and here it will be 8. Okay, now we have zeros everywhere, and the arguments are swapped. If we do AB here, I mean, why isn't swapping the arguments here doing anything? I don't understand. It's very confusing. I guess we're going to have to do some research on that. Oh my god, this is such a chore. Local inclusive scan, local scan. Reduces the individual thread elements. Scans the blockwise results. Okay, we're making sure to pass the correct neutral element here. And this should always be returning the left, so it should be 0, 0, 0. I mean, okay, I think I get something. Here we are always applying it with a neutral element, which returns 0. So even if it does a block reduction later, it doesn't matter since it's just a 0 everywhere. Okay, so that's one conclusion. Oh, let's return B here. We have to return B, otherwise it will also always be 0. Build file. So yeah, this goes from 0 to 15. What about if we swap the arguments? I mean, that should get the wrong result. Right now it's weird. We're actually trying to get the wrong result. Okay, and it's not the wrong result. Yeah, let's cancel them again with the calculated prefix. I mean, this just ends up tossing the prefix away, so it doesn't matter which order they're put in. For fuck's sake. How do I test this? Let me pause. I had an idea how we could actually test this. Okay, well, first let's put it back to how it was. And now, instead of trying to test this here, which really isn't working for us, what we'll instead do is go into the layers. And instead of this local reduce config, we are going to do a scan in addition to this. So, and we still haven't refactored this. Oh, for sure. Okay, let's factor this out into a function fab. Local inclusive scan. Okay. And what we'll do is print the queue. That should tell us something interesting. Wait, I ran the wrong thing. I need to build this and then run this. So it has a bunch of negative infinities, which it picks, because it's always picking the leftmost if both are wrong. But yeah, this gives the same result as before. But if we try swapping the arguments here, what will we get then? Wait, these are just a sequence of twos everywhere, so we need to... Okay, here is a tree, so that's the very last element. We'll have to repeat the experiment. Okay, here is negative infinity, negative infinity, negative infinity. Now it finally picks 3, 3, 3, 3, 3. Negative infinity. It finally picks 3. Okay, we have to repeat this we have to swap the arguments again. Then we'll go into this. Then we'll run it. And we have to make sure that it's doing the right thing on a tree and not just a bunch of random stuff. Wait, what the hell? Oh, for fuck's sake, let me close this. Okay, 3 is the first one, so if the arguments are in the wrong order, it should print out 12. But here it's still printing out 3. Oh, it's amazing. I mean, I guess the argument passing order into this really doesn't matter for this particular function. I don't understand why, but that's the case. I mean, the scan has multiple passes. Wow, I really cannot get this error to trigger. No matter what, it outputs the correct thing. I mean, the argument swapping does nothing. So, okay, let me pause here and I'll try to think of a even better test, but I cannot really think of anything at all. We should go into the... Yeah, into the closure. Okay, okay, here's what I will do. I mean, I should have thought of this before, but whatever. Let's see. Let's go into the... Okay, here's F. Here's the inclusive scan. Fun AB. We're going to put in a comment. Okay, then we'll build this thing, and now we do a search for VTF. And yeah, here we have it. And now what we'll do is print out Yeah, what I'll do is print it out. Okay, here's what we'll do. We'll actually print out I need to print it out inside this thread. AB. Okay, well, let's build this. And let's put this in a join point, so we can get rid of it more easily. Okay, we'll leave this fun right in here. And we'll also do a search for this in other places. And these are all of these places. We don't want them to print the argument. We just want them to print in the closure that's being passed into the CUDA reduce kernel, and that should tell us what we are standing on. So okay, let's do this. Oh wait, we must not build it. Instead, we have to just run it. Now let's see. A 0B1 12B1 12 8 8 4 12 1. So the left side is larger in this particular function, and that's proof that it's swapping the arguments. Now what I've done is the same thing as in the reduce function. And we are going to, let's build this again. I'm going to layers, and then we'll get rid of those other print functions. Not here, not the first one, but all the rest. Now let's run this. You know, I remember in the past thinking that I cannot really be sure whether the CUDA library function is passing the arguments in the correct order. But I said to myself, I'm sure the CUDA developers are doing the right thing. They aren't so incompetent as to pass it in the wrong order, but they fucking did. And now we have fixed it. Oh my god, what a waste of time this is. I'm fixing library bugs in the CUDA libraries. Oh, okay, wonderful. Wonderful. Yeah, we couldn't have figured this out without inserting a print statement. But now we're done with it. And I've actually forgotten. Okay, so Okay, we don't need this anymore. Alright, what did I... Okay, so... Fun AB. Okay, fucking finally. Now we still have to figure out how to share this randomly generated number across all the threads. I mean, we did that kind of thing a few times before. I'm just wondering how it could be factored out. Yeah, without the reduction at least will share it across the right threads. But if we just create a shared variable and randomly and just share it across every thread in the block, that won't be good either. Just a second. Did I remove pretty much every... let's put a bookmark here. Yeah, why am I even... yeah, I don't even need to reduce it with the J tensor. We can just return A. I mean, this isn't so bad. Oh, wait, we could pass R as the neutral element. What the hell? We could go over J tensor, and then on every reduction just simply return R, and either way that should get us some R. These are just the indices. Wait, would this be correct? How exactly would this work? I'm confused myself right now. Okay, let me pause here. I need to go have lunch. Arguably, I did some refactoring today. I came up with this. A map and reduce to share a variable. It's not really as easy as sharing a single variable through the shared memory. The problem is that we have to make sure that the registers are allocated properly. And if we look at, for example, the local scan, it does a scan or a reduce. They do their operations like not just a single time, but more than a few times. When we were testing out the scan, we had the scan function. We had the function that is being passed into scan being run 5 times, and that's all to ensure that everything is working in the right order. So it's possible to make this more efficient by making a version of local share, but I don't want to do it right now. If anybody wants to do this, if anybody wants to optimize this as an exercise, then be my guest. What I really needed to do was to optimize the memory allocations, because that's where most of the bottleneck in performance in GPUs is. But over here, it's we'd be able to share, by sharing directly, we'd be able to shave off some GPU instructions. That's for sure, but it's not where the main bottleneck would be. If anybody is watching this and wants to optimize this as an exercise, then please be my guest. It would take maybe a whole daily session to make a version to optimize all of this, to make local shared, so I don't want to do it right now. So let's move on. Okay, so what exactly is going on? Roma. Output softmax, output sampling. Okay, let me just run this once so I can reorient my brain on what should be done. Oh yeah, this is perfect now. It's amazing how many bugs there were in this. In fact, this test wasn't showing the error that happened in doing the test of the machine learning layers. Yeah, just the only thing that I'm afraid of is maybe the CUDA engineers will come in here later and fix this, and this would end up breaking the library. So there's no real point even reporting this error. It's actually better if it stays broken like this. I mean, the error of it passing the arguments in the wrong order. I kind of get the feeling that we should also be testing we should be making sure whether all the other functions are passing the arguments in the right order as well, but how do we do that? I mean, I'm pretty sure that it's, okay, let's just move on. I don't want to spend any more time in this, because it's we can be sure that at least the kernels that we have right now are correct, so there's no real point in questioning them any further. And yeah, indeed, at some point I really should just sit down and think about my testing workflow. But it's hard to do unit tests ahead of time. The unit tests are mainly effective on the bugs that you run in the past. And It's mostly effective if I could replicate all of these operations on the host as well, and then compare, one version to another. That way we'd have some, we'd have a GPU version and then a reference version on the host. I forget it. I do hope I don't end up regretting this decision. But you can always, doubt your code and do an infinite amount of testing. At some point, you just need to trust yourself and go forward. It's really great that we've discovered the errors that we had. Okay, so what do we do? Yeah, we should be testing the layers. Enough of the primitives. Let's move on. Okay, here we have something. Yeah, that something is. Yeah, it's printing out the output tensors and the output indices. I just got a thought. We were using the. What exactly? Where is the system? Okay, this is the semaphore. I have no idea what this is anymore. Right element system. What exactly is that? Oh, here it is. Basically, this doesn't work correctly. When we were using this without putting the sync threads at the very end, it gave us some very weird results. Can you? Okay, let's just do this like so for now. I don't really understand why this sync threads is necessary, so that's why I'm hesitating to put it in. Let's think. Suppose we have this right ln in an if branch, then the sync threads would break it. Whereas otherwise, the binary semaphore would ensure that only one thread could exit. Wait, thread grid. Okay, so this is how it's created. Yeah, in static memory, and we need to remember that static memory is global memory, and in global memory the variables are initialized by default to 0. The shared memory and the local variables are initialized, I would say randomly, but their initialization is undefined. They're mostly 0, but they can be arbitrary values. Okay, so we cannot put the sync threads here, even though it helps printing. But the printing I've noticed in CUDA is kind of buggy. Sometimes sometimes we can only print. I mean, we give it an tensor that has an inner dimension of 4, and it can print like 6 elements. It sometimes throws away characters for reasons unknown to me. Maybe the buffer gets filled up. I mean, we could report this to the CUDA guys, but never mind that for now. I'm not their beta tester. Okay, so we have the test 5 working. And this is okay, output probabilities. Let's just call them. No, not the action. Let's call it sampling indices. And this keeps around. This also keeps around the sample probabilities. Actually, it's not good to use parentheses. Yeah, like this. Okay. Yeah, I think we are done with this module for the time being. We have everything that we need. It's time to move forward. I mean, we should be integrating the game with the Ladakh. We've started this whole video by doing the front end, and we've been stuck on this for so long. I can't believe we even stopped to implement higher rank types. Oof. Oh my god. Yeah, this Glow 80 keyboard is great, but I just noticed that one of the legs came unglued. And where did it go? Okay, let me pause here so I can look for it. Just a second. Okay, here you can see me writing a complaint to Moergo, which is the company that makes these keyboards. I'm probably going to lose a bunch more of these in the future. It actually happened once more in the past that one of these come unglued and then got stuck to the bottom of the food tray, but I managed to accidentally figure it out by feel. It seems like this one probably got unglued like 5 days. I mean, this one probably got unglued like 5 days ago, and I didn't notice it. And you know, since my mom found a random piece of plastic on the food tray, she just threw it into the trash, because why would she ask me about it? It's a 400 euro keyboard, but it has, you know, I heard the complaints about the construction of this, you know, that it seems flimsy, but that's not really a valid complaint, because it's not really flimsy. The only real bad part of this keyboard is this stuff at the very bottom. I have no idea what to do with this. I mean, is it possible to actually buy these somewhere to replace them? But I also need to replace the glue on all of these. It's not really bothering me that this one is missing. I mean, the one on the other side is missing, so it's not a big deal that it got lost, even though I regret it. I did in fact have to buy a really big mouse pad, which I actually quite like. And just to keep this keyboard steady. For some reason, this table that I am using doesn't have much friction, and just resting my hand on the keyboard ended up moving it. Who knows, maybe if I got rid of all of these, they'd have even less friction. But never mind that for now. Maybe the reason why the table doesn't have much friction is because it's... I mean, one of the reasons why it doesn't have much friction compared to the mousepad is because it's not as soft. Right now, when I'm resting my hand like this, I mean, you cannot see it, but you can imagine easily resting my hand on this. So then the keyboard sinks into the mousepad, which makes dragging it along harder. I mean, it's kind of rare. I think that I'm the only guy who probably bought a mousepad just to keep my keyboard steady. But I guess it happens. Otherwise, I really like the design of this keyboard. It has a pretty much perfect design for a hand, for a human hand. The only thing I'd maybe do is put these keys on the side, you know, vertically. But it's not really a big deal. It's a huge improvement over the regular keyboard. There isn't a way to really improve much on it. Now let's get back on track. I mean, keyboards are an important part of a software developer's toolkit. I have this Moergo Glow 80 keyboard. I have this Logitech M575 thumb track mouse. I also have an Apple Magic trackpad. And those are my 3 input devices, or maybe 4 if you count the keyboard as 2. And I do like this kind of setup. It's not bad at all. Maybe I'll get an answer from Moergo about this issue. I don't wish that I have a bunch of keys, you know, put here, and they trigger too fast. And in order to stop that, I need to go to a tap preferred flavor instead of the hold preferred flavor. And okay, the keyboard does have this layout manager. You can just set the keys to whatever you want. Then you download the file, and then you just upload it to the keyboard. It's very easy to actually edit the layout. And in case you were wondering how I I can type the underscore very easily. I do that just by pressing Shift and releasing it. On a regular keyboards, you have to hold the Shift, and then you have to, with the other hand, press the underscore, which is next to the backspace, which is a lot harder. But over here, you can just press it very easily with the thumb. That's why you see me use the underscore so much. Sorry for this interruption. I mean, maybe you found that interesting, I don't know. Let's move on to the next thing. And the next thing is this game model M. I need to refresh my memory of what this is doing. I mean, I also need to test whether this still works. Yeah, I think we had some issues with the sampling probabilities and the selections. Sorry, I've been sneezing for a bit. And if let's get back to this. If I recall correctly, what happened over here is that we generated the output ID, and in the past version we tried doing a reduction over here directly, and that didn't work because for some reason that I can't really recall right now. I mean, it had to do with the order or of reductions. Okay, let's pause here, and I'll have breakfast, and I'll remember exactly what was happening here last time. I'm pretty sure the main reason why it didn't work is because the way the block reduction here was incorrect, and we had to generate the let me pause here. Okay, I'm finally done with breakfast, and I remembered why we did this. The thing about the main issue was that we were generating this ensemble ID, and every ID would be unique to a particular thread. So after we've done that, we've extracted the output probabilities here, and then we indexed into it with the ensemble ID. And then we did a reduction to pick the actions. And the problem with that is that every single thread would be operating on a different tensor. The way the reduction operation was intended is that the entire block would be operating on a single input tensor. But over here, because we were applying a random ensemble ID, it would turn out to be the case that every thread would see a different tensor. And that would lead to incorrect results. So that's why we wanted to extract the output indices. Oh yeah, we have them. We have that exactly here. Then we apply the block index, tensor index. Then we index into it. Oh yeah, now we have this weird output thing regarding the actions. Oh yeah, and because of that, another issue that we had is that the inner dimension for the entire tensor was simply too large. Like we in LEDAC, for example, we have only 3 possible actions, but the softmax was outputting a probability distribution over 128 categories. So we did a bunch of hacks, previously to get it to work, but I realized that this would cause the path probabilities to be keyed to a particular bin rather than a particular action. So instead, what we just did is used a masked softmax. And that, because of the masking, it would most of the actions would have the probability set to 0, and it will only be selecting from the first 3 actions. And we're going to have, of course, we're going to, the output ID for the LEDAC game, at least here, should be 0, 1, or 2. And we should not be converting it to a float. That would lead to all kinds of numerical issues. So yeah, what we'll do is just simply pass output ID into the output. And that's fine. Yeah, this is fine. Here we are taking the output probabilities, reordering them, apply block index, apply thread index, apply output ID. Yes, that's the output that's been picked. Right, block, thread, and inner. And we also have the ensemble. Yeah, the ensemble probabilities are just the path probabilities for each element in the ensemble. And the output ID, let's see. And this should be integer. Yes. Okay. I thought that I just leave a comment. Package score. Okay. This default in for this project should be I32 and F32. It doesn't. Yeah, it's okay to simply leave a comment in the project file. It really should be documented what the defaults the project is being tested are. The defaults the project is being tested with are. Sorry about dropping a word previously. I could say it's not so much that English is not my main language. And I'm not really that good at talking in general. Maybe I've been getting a bit better since I've been talking to the camera so much. I still talk a bit like a motor mouth. Yeah, I think it's not such a bad idea to do screencasting like this. You know, just to improve and get used to talking to the computer. Okay, so we have the action, the sampling probabilities across the sample, and we also have the selected sampling probabilities. Oh, that's this should be a float, I think. Yeah, definitely. Okay. Yeah, I've out of the indices. What about the output probabilities? Shouldn't we also be? Oh yeah, here we are testing for them. Ensemble block thread inner. And new output ID is indexing into the inner. Yes, yeah, it's perfect. I mean, actually, let's do this a bit differently. This tensor indexing here, we don't need to apply one by one. Instead, what we can do is block index, trend index, output ID. Yeah, this way of doing it is a bit more succinct. Let's put it like this. Yeah, now it looks a bit nicer. And we can do this on the same line as well. Yeah, now we've increased the density of information for per page. Well, and it's still readable. Okay, I think. Okay, here we have. Here we still have some issue. Like, where is the game model? Game model M, but here's the type. Let's change this to int. Yeah, okay. And we've come a long way. Now we should have a proper action selector. Let's go back into the tests for the training. Refactored game model M. Now we are finally back here. Okay, let me think. This is test 1, test 2, and those are just testing the serialization. Test 3 is actually testing it's actually testing the, what do you call it, model. Yeah, we need the masked softmax. We can get the masked softmax using PU history size. The other information here is takes the modulo, the upwards modulo of PU size and 128. So that ends up being just 128 in this case. But the PU history size is on 128, but probably something a lot smaller than that. So masked softmax and pair first there. Okay, do we still need this tensor d3 int? I don't think we do. Let's clone this properly. And where is this? Let me just take a look at the layers here. They have this assemble blocks per grid. Oh yeah. We need to pass in the PU history size as the first argument. PU history size. Oh, not bad. Not bad at all. Oh yeah, now we have this output thing. Excuse me for a moment. Now, I just had my doorbell ringing, so I had to see what it was. It's not a big deal. Okay, here we have, here we are now getting the output ID. And we'll do the same thing that we did last time, match I with. In fact, we can just do a function. 0 fold 1 call and 2 raise, and for anything else we'll just throw an exception. Fail with invalid. Output ID in the LADAC model. Fail with Yeah, now we have our game model. So we are using layer norm followed by a rare new. I mean, well, it's kind of weird. While I was testing things, I found actually I'm not sure whether layer norm should be followed by ReLU or if it should be ReLU followed by layer norm. I know that one of those works really well with nans and the other one doesn't. But I think the other version works better for RL, and I don't really understand why this was happening. While I was doing testing on various machine learning models back in 2021, instead of even using something like ReLU, I was using the power activation function, which is just the cube function power of 3, and then that's normalized. But who knows? The thing is, I'm actually maybe I want to ask about this on the machine learning subreddit. But the thing is, even though a lot is known about which architectures work on with backpropagation in the supervised learning domains, I'm not at all sure whether those same architectural tricks are necessary for, I mean, when trained using evolutionary algorithms. Yeah, this is something that's new to me. We're going to have to think about that going forward. And the one thing that I am concerned about is that it's actually very difficult for me to understand even to how we'll compare the architectures against each other, because here we have one architecture and it will mostly be trained by having the agent play against itself. It's not really like in the supervised learning domain where we can just we have a static data set and then we can see how fast the loss goes down. With this, we won't really have a straight up loss. At most we have is the how close the loss is to zero. But the loss can be zero even if the architecture and the agents are bad. Maybe it gets stuck in some local minima. So it's going to actually be challenging to figure out which architectures are good for reinforcement learning. I guess that's something we'll simply have to deal with. Maybe we'll make some static player and then test various architectures against it. Just we'll see how fast the agent improves. But the problem with that is that it will still be like reinforcement learning training, and that has high variance. If you look at the reinforcement learning papers, they always train on the test set, and that won't be very different for us, because essentially training takes a long time. Who knows? I guess the only thing we can hope for is that there have been some interesting papers that I've missed since 2021. Who knows? 3 years. That is some time to make some progress on reinforcement learning. We'll see. It's important to just get better at this. We'll focus on making that agent. Maybe we'll use a basic architecture with not even player known and tanh, but simply ReLUs. We have the ensembles. Yeah, matmult, tanh, matmult, tanh. Then this one at the very end, and that should be enough. I mean, to start us off with. So let's think. Okay, here we have the same data for every single input. I guess that's fine. So what do we want to do here? We have size, test graph, parametric issue and game model. Then open tensor M. I mean, do we even need the tensor here? Range, open range M. We don't need this either. Oh, and it is printing some outputs. Oh yeah, so it's printing the actions that are coming out of the game model. Okay, I see. Yeah, I suppose this is good enough. Let's try running this and we'll fix the errors that come out. Okay, I built the file and it seems it compiled the first time around. That's good. Invalid output ID in the duck model. Wait. This is PU history. That's oh, I get it. That's the size for the inputs. Instead, we need the size of the outputs, and those can be only 3 different actions. What the fuck? Like, what kind of actions is it even getting? Okay, I guess we'll print out everything. You know, when I said that we're going to fix the errors as I come along, I was really hoping that we wouldn't have any errors, and I wasn't really actually expecting them to have them. But it's amazing how my lie turned out to be truth here. In the output function, okay, we have the okay. Let me comment this. Let me copy this. Comment this out. We'll just return the int that's coming in. We'll see what that results in. Oh, come on. Now let's run this. So we're getting all kinds of actions. Okay, but why? Let's take a look at the output probabilities and the output tensors. Let's see. It's the easiest thing to do would be to just copy it from one of the layers tests. Let's see. This thing. Okay, I mean, we have a wide variety of actions. Okay, this is just the first 3. As you can see, all of these are 0, so why is it picking all those actions? I'm confused. Okay, all the output tensors have probabilities condensed in the first 3 elements. So it's weird that we're getting this kind of outcome. But maybe it has something to do with that this is such a large tensor. I mean, the inner dimension has so many elements. And previously we were testing it only on a tensor of size 16. I keep getting interrupted during my workday. We need to figure why this error is happening. Softmax and discrete sample. I mean, what could it possibly be? Let's go into the layers then. Test 5. Okay, let's make this like 3. And we'll make the inner dimension 128. Inner and 128. Inner. Okay, now let's build this. What's going on? Input and the output tensor dimensions have to be equal. And oh yeah, I forgot to put inner here. And now let's take a look at the layers. Is it picking just the first 3 actions here, or is it doing something else? We'll see. Yeah, we have an error here. So the discrete sample isn't working correctly. Okay, let's go into the primitives module. We're going to, I think, just comment out all of these. Let's build this. Yeah, when we have the small number of inputs, it works, but let's make them gradually larger. Like, let's make this 4 and let's make this 8, and we'll see what happens. Oh yeah, it's super wrong. You know how I was saying that I hope I don't regret not testing out whether the order that the inputs are being passed into these functions for the scan, and I guess I also should have considered whether it works properly with the larger dimensions. Yeah, now I'm regretting this. If you look at the outputs, here we have 1, 1, 0, 124, 124. Yeah, that's not right. I guess we'll have to get to the bottom of this. Okay, let's reduce. Let's make this like 6. Let's make a minimal example, so it will be easier to debug. Oh, with 6 it seems like it works. Yeah, the 6 divided by 2 to the power of 6, that's 64. And when we divide that into 4 element pieces, that ends up being 16. So it can still be loaded in a single warp. I think then we should also expect it to work with the input size of 7. But we did have an input size of 7, which is 128 elements, and it didn't work previously. Okay, I see. I mean, another thing that's weird here is that the errors, for some reason, in this test are different than the ones we get in the other one. And that's a bit confusing, I think. But anyway, we're going to have to figure this out. We need to debug this. Okay, so what could possibly be the problem here? I mean, it works with the smaller inputs, but not with the larger ones. So the softmax here seems perfect. So the only problems in that case will be the reduction. Whatever. Let's take a look at here. Masked softmax, local discrete sampling. Could this part be wrong? I mean, it's not like I tested it thoroughly. Okay, just out of curiosity, what would happen if I did, like, instead of this const, build file, and the main difference is that now it will have every element will have its own probability. I didn't change a thing. Okay, so that's not the problem, I think. Inclusive scan sum. Okay, let's do write ln system semaphore x thread id thread index and sync threads. Okay, let's see what's getting printed out here. The very first input is, the very first output is 124. Okay, that makes things easier. I mean, there should be 3, but maybe this 3 is on the second element. Okay, we have 32 threads. And every thread has 4 elements. So that is a total of 128 elements. So yeah, I should be picking this one. But you know, a lot of them are the same, so it might be getting confused. Yesterday, what we changed is the order that the elements are getting passed through in the reduction function. And the kernel does depend on that being correct. Let me think. Yeah, if there is a lot of cases where they are equal, and we want to return the leftmost one. So we do in fact have the index itself. So if we wanted to impose an ordering, we could do that by comparing the second element of the pair for A and B here, and that would make it correct regardless of how the kernels are implemented. But I do think we're having some ordering issues. But you know, if it really was an ordering issue, why are we getting 124? Shouldn't we get 127 in that case? Like 124, that's 3 elements left from 127 from the last one. How could that possibly be? Okay, let me pause here. I'll put some print statements and get to the bottom of this. Hopefully, by the time this is done, we'll completely have figured out the correct ordering for the reduction function. And I'm still not sure whether it's a matter with the ordering, even though it probably has something to do with it. Wait. Oh wait, I haven't really paused yet. I just got an idea. Like 124. That's like the first. It's not necessarily the case that it's 3 elements from the last one. 124. That would be the first element, like here. So maybe locally the ordering is correct, but globally it isn't. Let me just try out something. Okay, the inclusive scan. I guess that doesn't really. Okay, we'll have to think about. Okay, let's go into the cooperative groups. Okay, we'll change it back to how it was. Let's see whether this makes any difference. And keep this fucking thing open. In fact, I can just do this. Oh yeah, now it works. We've switched the argument order, and now it's no longer giving us incorrect results. But okay, that's one thing. But suppose we instead made it 4. I made this 8. I remember having a similar issue in the past where the reduction operation was doing incorrect indexing, and it got one test that would work on map. After I applied a fix, would stop working on the reduction, but I didn't realize it. So this change that we did ended up causing a regression. So I guess this is a good case that we should have unit tests, even though I'm not really convinced just yet. Yeah, now it's giving us 12 for this smaller example. Of course, if we switch the primitives, I think it would, like, if we switch the arguments, it would start working again. What if we switch this? Does that change anything? It shouldn't. Yeah, it doesn't. Yeah, yesterday I talked about how maybe the swaps are canceling each other out on maybe that the swaps could potentially cancel out on a bigger example. So okay, what I want to do, we're going to be printing things out. Let's put a bookmark here. Then we'll go into local mask softmax, and we're going to do and I don't really like doing this in a reduction function. I mean, this, we cannot really put async threads in a reduction function, I think. What do we think? I mean, why couldn't we? I mean, okay, let's just do it like this, and we'll see what comes out. Yesterday we only printed out the values in that are coming into reduction function inside the cooperative groups one, inside of this one. But now we're going to test for all the functions. We compile this, and if you look at VTF, we should see it in a bunch of places. Really, only 2? Oh, I'm surprised that there are only 2. When we were testing this in scan, it was in a couple of places. Okay, it doesn't matter. Okay, let's just run this. Yeah, now we get a bunch of nans because I mean, the stuff on the left is only 0 as it's B. Yeah, it kind of breaks things. I mean, I don't see any indications that the order is wrong, but this waiting on the semaphore does break quite a bit. Okay, let's instead do a right ln block we'll see what happens then. We only have one block for this. We're only using the one block on the entire GPU anyway. The printing breaks things. I don't see any indication that the arguments are being passed in the wrong order. Okay, the arguments have to be passed in the wrong order. My mind is telling me that. It's so difficult to... Sometimes, I guess it's difficult to do printf debugging in CUDA. I didn't like debugging this reduction function, and people just keep going into my room. I come to think of it, we only have 32 threads in a block. So sync threads is about equivalent to a warp sync. Okay, whatever. Let's try. No, I mean, the semaphore light element block should be about equivalent. I mean, it's going to have a... It's going to have what? It's going to have sync threads at the end of it. Right element block, acquire lock, right element, release lock. Oh, it doesn't have sync threads. Okay, whatever. Well, let's do this. I need to overcome my fear. Wait, right element block. No, it doesn't have a sync threads. And we only do some sync threading when actually creating the binary semaphore, but otherwise we don't. Okay, let's try it like this. Wait, did you even build this? Why does the semaphore have a... Oh, for fuck's sake. Okay, right element system. Wait, did I forget something? What's going on here? I mean, previously when we did this, it at least compiled. Oh, something is happening now. Eight 12. Oh, and it seems like it got stuck. It's in an infinite loop. I guess something went wrong with the semaphore. For fuck's sake. It's so difficult to do proper debugging. Especially when compiling for Python. I think if we were targeting straight up C++, we'd be able to get our hands on some actual debuggers. Right now, they are kind of... The problem with printing is not so much the printing, but the fact that they are data arrays, and it's difficult to do a print while having it contained on a single thread. So maybe what's necessary is to do the printing, but also to output all of that as a single string. Maybe we should modify the console print function so it concatenates all the inputs in a string and then outputs them. I think that should resolve our printing issues. Right now, we've done this, and it ends up splitting pretty much all of the printing sub-tasks into multiple elements. Yeah, we could use a compile time cache map to keep around the intermediate elements. This would make concatenating the input strings easier. Okay. We'll consider that, but let's forget this for now. I'm still convinced that there's something wrong with the order. Like, we change the order of the arguments, things get fixed. So, but to begin with, this CG reduce. It works. This works for small inputs, and the opposite works for large inputs. But this should only be called the cooperative group reduce for the subtasks. I mean, it cannot possibly pass in the wrong inputs in one example and right inputs in the other. Well, yeah, we really might end up working on the print statements. I really want to print. I really wanted to print things out properly instead of print things out incorrectly. Maybe we could even add a printf operation to the language. Okay, no, right. For that for now. I want to understand where the cooperative groups reduce is getting used. I mean, it has to be used whenever So it's just used in like 2 places. And one of these places has to be wrong. In fact, we could make it be used in just a single place. Like we could just put all this in a drawing. Oops. Like this. Build file. UTF. Now we have a single device function. It takes in a float int returns a tuple. And this does return a sensible tuple. This is the left side, this is the right side. And this is, okay, this is the right side, and this is the left side. I mean, okay, it does make sense, and I think this is definitely right. Now we can look for uses of this. Let's meta 0. Okay, here it is swapping the arguments, and this is in a closure. We could add a custom print right here in the generated code and have it, just so it prints out the arguments correctly. Wait, what? Like, didn't we already have this? Oh, this is just the declaration. Here it is calling it in the closure. This is the actual implementation. And this is 26, 27, 34, 35. Here it is passing them in the correct order. Okay, let's do this. Print f. And then v227, v235. What happens now? Oh yeah, I forgot to put in a new line. I always forget that. Why are there so many commas? Okay, let's try it again. Mm. 12, 13, 4, 6, 12, 14, 4, 6, 3. Okay, let's do a proper like this. Wait, and this might end up putting... No, it shouldn't. Because we're using, at the top level, a Python raw string, I think. Okay, 12, 15, 8, 11, 4, 7, 0, 3, 12, 5, 12, 15. Okay, and this actually does give me an idea. never mind this for now. Let's go over here. And we'll print it here. And instead of printing it, what we could have done is simply put in an assert that putting a print statement here is causing some trouble. Yeah. And this should be v1 and v4. I mean v3. Two 804. Okay, so yeah, now it completely works. We need to move on to a bigger example. Okay, what we'll do? Okay, we'll just macro in printf, and okay, let's. Before I had the functions in the console module, I was just macroing in the printf statements like this. And now we have a lot of evidence that the way the console module works doesn't work properly. So we should redesign it, especially now that we have compile time hash maps. We are going to have to put in string concatenation into the language though, just to make this work. And maybe I should even put in a string builder, compile time string builder type. What a drag. Never mind that for now. Okay, here we have this, and this needs an extra slash. This one is second A, second B, and there should be an int, right? Yeah, it's an int. Let's build this, and we actually don't need a semicolon here. It will put it in automatically. And now that we have this tool for debugging, let's go into the, let's put a bookmark, then let's go here, and we'll set this to this example. Build file and run. Okay, here we have 76.1, 176, 84.1, 184, 92.1, 1. Oh yeah, this is not good. And where is this method getting used? I want to understand. Right now we have it in. Here's the for declaration. Here it is in the closure. Here is the actual implementation. Here it is being called here. Oh my god, this is so fucked up. I have no idea what to think about this. Okay, I want to understand whose fault this is. We're going to copy this file. Let's comment it out here. And then let's go here. And this is, we're going to copy this, put it here, copy this, oops, put it here. And I mean, they should be passing it in the right order, I think. We'll build it. And right now the only question is whether my own code is wrong or whether Nvidia is doing something strange. I think it's more likely that my code is doing something weird. 124, 127, 16, 19. I mean, this is my own code and it looks spotless. Wait, I should put a... inside 24, 42, 8, 12, 12, 8, 16, 20, 20, 16. Oh, what the fuck? Oh, this is crazy. Okay, let me just take a look at where this closure for is being used. Label partition, and this is tuple 1. Okay. Okay, this is one thing. The one thing I'm wondering is, okay, this is for a large example, but if we okay, now where was I? Yeah, this is for a large example, and for a small example, it should of course work. Like, is it being used anywhere other than here? This closure for, like, no, not really. Okay, this is a genuine Nvidia library bug, and it's very weird that it is happening. So, let me stop here for a bit. I need to take another break to think about this. I'm probably going to do a bug report for Nvidia. Okay, what we're going to do here is create a bug report for this issue. We'll send it on Nvidia after that. Okay, now where are the primitives? Well, create. Okay, let's copy this. Reduce test. We're going to put this on a separate branch, just for, or maybe on its own commit, just for so the Nvidia devs can access it easily. And we're going to simplify it a bit. Like we don't need. We don't need all of this. Well, let's see. We have the input identity here, and that would be good. We have the input identity. Okay. First of all, let me print out the input identity. Yeah, in fact, we don't need all this. Oh, for fuck's sake. Let's just get rid of most of this, and we'll open primitives. Just reduce. Maybe we'll pass in m and n as arguments later. For now. Now, where's the input identity? I mean, output identity. Output here. Open CUDA tensor CUDA. Wait, it was complaining about the meta variables, and we'll print it out. Output Okay, so far so good. Okay, let's close. Let's build. Let's see what comes out of this. And we'll do an assert here. No, we'll first do error reduce, local reduce config. Let's make it -1 fan AB. Assert A less than B, and let's pass in X, and we'll also output X. Okay. Expected 8B. Now let's build this. And if we put, if we do this, yeah, it also fucking fails. Like, did I even build it properly? Oh yeah, forget the print. I thought that at least one of these would work properly, but it seems none of them do. What's the problem here? We're trying to print out the tensor. If we get rid of the assert, what happens then? Yeah, it ends up outputting -1 everywhere, which is, yeah, this is something you'd expect. What about if we put in B? Okay, where's the output? The output is 3, 19, 35. What the hell is going on here? It should be maximum 16. Yeah, it basically cannot do the right thing to save its life. And then now I am unsure myself of whether the code kernel is the one at fault or whether there's an error in my own code. Oh, this is just so bad. But I'm pretty sure CUDA definitely does have an error, even though I cannot be sure that my own code is bug-free in that respect. Okay, so we're going to be sending this example to Nvidia, but I need to clean it up even further. What I'm feeling right now is to forget about this bug for the time being. And what we could do is redesign the console module. Like this bug can wait for a bit, but proper printing cannot. I want to do the printing like right now. We're going to have it work on. We're going to have it hold a hash map, and then we're going to put all the format strings in it, and then we'll concatenate them at the end along with the output targets. That's the way things should go. Okay, let me think about this. No, I really should take care of this first. So how can I ensure that my own kernels are right, but that the CUDA kernels Okay, first of all, let's put this in a join point. Okay, pinol, what do I name it? Return second. Let return second. Return second. Now if we compile it, return. Damn it! Don't we have? Shouldn't this join point be named now? It's return second 0, okay. And we need to put the print statements everywhere. This function is being called. And it's being called in only two places, here and over here. So yeah, and having a proper print statement would make making this example easier. You could just go into the cooperative groups thing and then put a print statement in order to assert, in order to print out what's going on in the closure. And we could also find this other place where the function is getting used in my own reduce and put the print statement there. And that would clear up everything. Yeah, we're going to do that. Okay, Nvidia guys, wait a moment. I'll be with your bug report soon enough. Let's let's close all of these. Yeah, as you can, I mean, a pragmatic thing, if I was on a deadline here, would be to just just put in indices, just to put in index checking into the reduction function itself, and that would make it irrelevant which order the arguments are in. But over here, I want to do the right thing, and the right thing means having a complete mastery. And the right thing means exploring the search space properly. So let's do a test, main, and then write ln a equals 1 i32, b equals 2f32, c equals d equals true. Let's start with this. Let's build the file. And if you look at this here, oh my god, this is awful. Like it has a bunch of print statements everywhere. It has a bunch of methods. Okay, for now, I know I put in join points as an optimization here, but let's get rid of them. Instead of having a let, we'll just put in an inner log here, and that will, yeah, now it will inline the print statements, and you can see exactly how many we have here, and we do have a lot of them. And what we want to do is put all these formatting strings together. Actually, it would be more illuminating to do it on the CUDA side as well. But for now, I guess we can do it on the Python side. Okay, what we should do is maybe represent this entire thing as a GADT. Yeah, we could go over the entire type, turn it into a GADT, then actually print out the GADT. First, we have to also take care of string concatenation. We need to do something to be able to concatenate the string literals. Okay, let's start things off by extending the spiral language. We'll first do a test of string concatenation. And s. Okay, let's do. Oh yeah, how are we going to do it? Let's do string static string concat. In fact, in the past, Spiral, at least in the old version of Spiral back in 2018, we did have string concatenation, and it was dynamic. But back then we were only targeting the F# backend, so it was a lot easier to do there. Over here, we cannot possibly have a dynamic string concatenation in the CUDA backend. I'm not going to do it. So QA ASD and this should return a string. Let's extend the language. I have to go into block parsing first. Serialization helpers. I guess we'll put them. Okay, here's the string. Let's put them in string operations. Static string concat. Now we'll go into the partial evaluator. In fact, let's just copy this instead. I want to press Ctrl D, but Ctrl D doesn't really work that well in Visual Studio. Visual Studio Code is much better as an editor. And that's simply because it has some sensible shortcuts. Static it has only a single input. And it will either take a string literal or just a string. Let L equals term SL. And we'll do a loop here. Let rec loop. And let's make it a function. And okay, here we have the pair AB. And that will just be. In fact, let's do a string builder. Let string builder system text string builder. Oh yeah. We want to concatenate all the strings. So we'll do it like this, and then delete a string. And then if it's a string, we just add it to the string builder. Append X. And otherwise, it's a type error. Raise type error. Expected a compile time string or a pair of them. Got X. Oh yeah, not bad. Okay, this would return a string builder, so we just ignore it here. Now, what we need to do is simply call loop VL. Yeah, no problem. We can even do the evaluation right here, so we don't need to use a temporary variable. So loop L, and what we need to do is deal. And this X here is string build to string. Oh yeah, we also need to put in parentheses. Oh, not bad. Oh, now we have static string concatenation in the language. It's nice and easy. We're going to try it out right away, in fact. VS Code plugin. Oh, static string concat. Wait, did we? Oh fuck, it didn't build. Oh, it's so fucking slow to compile. And as you can see, it's very easy to add an operation to the partial evaluator. It doesn't, especially if it's something like a compile time only operation, it doesn't touch any of the other passes, so it's very easy to do. Features that are hard to add are the ones which touch many other parts of the code base. As a general rule, the more isolated you can make a feature, the easier it will be to implement. Okay, so here we have the CS string. Okay, let's try running it. We'll build, and what we get at the end is QVA ESDZXC. Suppose we have something like new line characters, something like this. Oh yeah, this is nice. Oh, not bad at all. Suppose we had something like a character like this. How would it get printed? QVAL. It would get unescaped. Or maybe it would get escaped. I'm not sure which one the word is supposed to be referring to, but only special characters which inspire our new line, return, carriage, and tab and back get printed with this slash. But if you wanted to print anything, suppose we did it like this. We could, yeah, we could also. This slash last gets printed as you would expect. Okay. I guess we could put row strings at some point into spiral. Never mind this. So we have this thing, concatenation function. So now what exactly do we do with it? We have the write. And it occurs to me that this is actually a pretty great spot to use higher ranked types. So, okay, this is actually, yeah, now we have the object, but we could write it very differently. Let's think about this. Okay, here's the primitive x. This is what returns the format. Okay, I mean, we're probably not going, we're not even going to use a GADT for this. I'm not going to synchronize the changes just yet. Who knows? I mean, it's impossible that anybody is using the machine learning library, but I don't want there to be type errors in case anybody tries to load it. So if you could prim. Okay, let's do this. Console2, and we'll just copy paste everything here. It's going to make it easier to edit it. So here the prim, and we can feel free to break everything. We have the write xt, and we have this write x object. We could use a compile type hash map. P write a write. Wait, why does this have to be recursive? It definitely shouldn't be. Okay, write L. Write ln, we'll comment this out for now. Separator. Okay, I need to pause here for a bit so I can think about it. I have like two different competing ideas in my mind. The first one is to do it all in bottom-up style, and the second one is to use it as a try to first convert it to a GEDT. We'll see which comes out on top. Let's get started. I want to do some programming for the day. The mic does work. Okay, yesterday I wrote a message to Moergo and I got this reply. So let me show it. Hello Marco, this is Stephen, the course designer. The global tenting mechanism. Okay, blah blah blah. And basically, what they showed me is that I do in fact have replacement silicone bumpers for the keyboard. I lost one yesterday, and it seems they'll be implementing the hold tap soon. And this is the email that I sent yesterday. Okay, so let me send the reply. The only thing I added to this conversation is that the dust accumulation on the pads is much lower compared to my old desk. So it wasn't a bad idea to get it. And this is actually a very professional response. I'm glad that they took the time to it. Otherwise I wouldn't have realized that I had replacement pads in the travel case. With the keyboard I got a fairly large travel case. It's like something like this big, if you can see it on my hands on the camera, and it's very nice. But I hadn't really touched it for nearly a year, so I forgot what was in it. And those silicone pads are just in some glue paper. I'm not sure how to describe it, but it's kind of it's easy to actually forget that it exists. I didn't even realize that those were replacement pads when I opened it for the first time. I only realized it just now because of this email. And I do like this company. The reply was very professional. They took the time to address my concerns. So I do recommend getting the keyboard, but also do get the mouse pad instead of just using a table, because they mentioned that okay, where is the fucking? They mentioned that they did some pretty fancy testing to make sure. Oh my god, the Thunderbird is so damn slow. They mentioned that they do. In fact, we used float glass to test during the design phase. The QA keyboard made in the factory. So I have no idea what the float glass is, but of course I know what glass is. And before I got to this new desk, I was using an old wooden glassy desk, and it's actually the dust accumulated very quickly on that particular desk. But over here, I look at this now. This hasn't been cleaned for quite a while, and the only dust accumulation that I can see is at the very edges here. But previously, it was centered on the silicone pads themselves, and once that happens, they pretty much lose all friction. So whatever you do, I do recommend getting a mouse pad if you have this keyboard. And I'm probably going to do a review video for it at some point, much like I need to do a video on how to do this mouse pointer. I mean mouse pointer highlighting. So, okay, enough of that. Let's go back to programming. Yesterday, I again made the mistake of playing XCOM too long. Now I cannot, and I couldn't fall asleep properly, and now I'm tired. But it's not at an extreme level. But of course, tonight I'm going to have to go to bed earlier because otherwise I'll drop dead. I cannot keep doing these marathon gaming sessions. You know, at 12 p.m. I kind of know that it's time to stop, but I wanted to do just one more fucking mission. And yeah, it's fucking great. You know, when you're in that state, you know that the game is fun. And I'm finally getting a grasp on the long war. The previous mod wasn't really, which was the original long war, wasn't really doing it for me. But the long war balance is just right. It's great. I'm really feeling like a master strategist when I play this game, and actually I'm good at the strategy games, I think. But the first fucking long war, it was like crawling across the map and overwatching everything. I just couldn't get a handle on it, and I wasn't even good at it to begin with. I didn't even grasp. There are a ton of unit abilities in this game, and it was hard to get a grasp on it. But now I feel when I look at the game, I finally get a sense of the proper strategies that needed to be used. And yesterday we were working on this. I did get actually on this. I did